Hello and welcome to the demo of our project Macke. The problem that our tool tries to solve is that of finding a vulnerability, a buffer overflow to be exact, that lies somewhere deep in the program. A program that has a call hierarchy as shown. Symbolic execution would start at the entry point of the program and try to cover as many paths in the program as possible without really trying to look for a particular kind of vulnerability. A problem occurs when symbolic execution may get stuck in a complex or time-consuming set of instructions somewhere shallow in the program and completely miss the deep-lying vulnerability. Our solution then is to first break down the program into isolated components or functions in case of C language and use symbolic execution on each of these components separately. One has way more chances of finding the deep lying vulnerability this way because all vulnerabilities are essentially shallow when components are executed in isolation. Reaching these vulnerability then is just a matter of finding feasible paths to the vulnerability without wasting our time in paths which are not interesting to us. Our tool Macke does all of this, and it does it in the following way. First, it starts by separating all the functions of the program for symbolic execution in isolation. Then it symbolically executes all isolated functions, and for this we use CLI, and we record information about all potential vulnerabilities, and also we record statement coverage for every isolated component. We combine the information from step 2 with the statically generated call graph and partially covered paths, which we also get from 2.1. For uncovered function calls, we replace the function calls with concrete values, which lead to a vulnerability, and then run symbolic execution again, but this time only with target assertion statements. Next, we combine all the vulnerability reports into an interactive web-based graphical report with individual severity scores. Let's start the demonstration with the first step of generating isolated functions for unit testing. For this demo, we apply Macke to grep, which is an open source Unix utility. Let's start by looking at the source of grep, which is a Unix tool. Let's go back to our Python tool and run the command batch separate units. Batch separate units command would use libclan to read the source code and create unit test files for all the functions in the source. Step 2 is to symbolically execute the isolated functions coming from step 1. So we call our script batch cli on the folder containing source of the project rep. All the output that you see on the screen are actually outputs from cli. We can also find the buffer overflows which were found during the unit test of isolated functions. The first part of step 3 has been automatically completed by Macke by replacing function calls with assertion statements. We move on to the second run of CLI on isolated components, this time with targeted search enabled. We go back to the tool folder and run the second step of compositional analysis. As part of Macke, we implemented targeted search as an additional path search strategy in CLI. All rounds of symbolic execution are complete now. This brings us to the last step of compositional analysis, which is to compile all the information into an interactive graphical report. The figure that you see on the screen is the call graph of the whole project grep, and all of the nodes represent functions in the program. Let's start by clicking on one of the functions. The function dfa exec contains 6 test cases which resulted in a buffer overflow. We click on one of those test cases and we find that the tool tells us the file where the error was located, the line number, the call stack. On the main page of the visualization tool, user can change the values for impact factors such as bug chain length, distance from an exposed interface, etc. to reassign new severity scores depending on the context of development, environment of usage, and so on. As a final step, you may also download the report as a PDF file which contains all the same information as what you see in the web browser. We hope you enjoyed the demo.